Hi, I'm Alexander, and welcome to this walkthrough of how to create a RAG chatbot using SurrealDB, Python, Streamlit, and Ollama. What we're going to do is first create a SurrealDB Cloud instance, then we're going to go through the Python code, and then we're going to look at the user interface. So let's get into SurrealDB Cloud. You can get here by going to app.surrealdb.com. or by downloading the Surrealist desktop application. So the first thing we're going to do is deploy a Surreal Cloud instance. So we're going to go to free, then we're going to untick the initialize with a sample dataset tick button, and we're going to rename it. So what we're going to rename it here is Flork. Now, that doesn't make any sense at the moment, but it will in a bit. Now, let's continue and deploy the instance. Now that we have deployed our instance, the first thing we're going to do is just create a namespace. So the namespace we're going to create is just called chat, and we're also going to create a database called chat for simplicity's sake. And also what we need to do is we need to create access credentials. So I'm just going to create root access credentials here with a not very safe password, which is, of course, this is not a very safe password. You should have a safe password, and you probably should not have a root user if you're doing this in production. But for simplicity's sake, this is what I'm doing at the moment. So now we have a user. Then what we're going to do is that we're going to go and connect with the SDK. So this menu gives us an overview of the different SDKs that we connect to, and we're going to use the Python SDK. So you can see we need to install it, and here is a sample code of how to connect to it. What we need just for now is this connection string that we're going to input into the .env environment variable in VS Code. So that's it for what we need for Surreal Cloud for now. So let's go into VS Code. So here in VS Code, we have the .env environment, and we have the Ollama URL, which is localhost. I'm just running it locally. Then we have the SurrealDB URL. So we just got that. And then we have the username and password that we created. Now, of course, this instance will not exist by the time you're watching this video, so it won't actually work. And also, never show anybody your .env environment variable, but we're showing it here for illustrative purposes. Now, how do we actually get here? So what we did by getting here is this setup part where we created a new folder, and in the command line typed uv init. So uv is a Python package manager that allows you to work really nicely with virtual environments and add dependencies. So the first thing we did was add uv init, which initializes the project, and it creates all the files you see here. So it's add git ignore, add Python version, adds your Python file, the pyproject.toml, readme, and log file. And the second thing we did was add our dependencies. So the dependencies we need are, of course, SurrealDB, Streamlit, Ollama, and Python.env to read the environment variables. And later on, we're going to actually run this with these commands. So you can do Streamlit run app.py, which launches a new window, or you can launch it silently by adding the server.headless equals true. So that is what we'll do a little bit later. But now let's go into the actual code that we're going to use. So here we have our code that we are essentially importing. So we're importing OS, which is how to interact with the operating system, and we need to use this with the .env to get the environment variables. Then we have Ollama. We're importing the Surreal class from SurrealDB, and then we're just importing Streamlit as st. Now we are loading the environment variables and basically setting the Ollama URL and Surreal URL from the environment file. And then we have the code of how to actually sign into Surreal Cloud or SurrealDB locally. So first we instantiate a Surreal class, and then we essentially sign in with the username and password from our environment variables. And then we created the namespace before chat and a database chat, and we're going to use that here. So that's it for the setup portion of what we actually need. And now we can actually go into creating the logic of what we need. So the first function we're going to create, this function initializes the database and creates the vector indexes we need. So we have this db.query, and the db.query essentially allows you to put query strings or any type of SurrealQL into the queries. And first thing you might want to think about is variables and in avoiding SQL injections, and we'll get to that in a little bit. But for these queries, there's no input we need. So here we can just create our indexes and a table called chunks. So we have the table, we're creating an index on the table for the embeddings, and we're using the M tree with the cosine distance. So we're going to do vector similarity based on cosine distance a little bit later. So what this function returns is essentially a st success, which is a kind of message to the Streamlit user interface, basically saying that database initialized successfully. So the second function we're going to have is a function called split text. So this function essentially allows you to split a huge text into manageable chunks. And this basically means that you don't have to search through the entire corpus of text. You can have it in chunks, which means that you can actually have more refined context. So you don't have to have like an entire book or something. You can actually have only the context you need. And then we have the other function that basically stores those chunks in SurrealDB. So basically, for every chunk, we create an embedding for that chunk. So here we're using Llama 3, just because I have it installed on my computer, but you could use nomadic text embed or other more efficient text embedding models. Now, we have another query here for SurrealQL, which is basically insert into chunks. And so here we're inserting both the text, the raw text, and the embedding text. So the embeddings created by the OLAMA model. And here we have the query parameters. So we have the db.query again with the query that we prepared here. And now we have the parameters. So parameters in SurrealQL are specified by the $sign. So here we have the text field with parameter text, and then embedding field with parameter embedding. And so here we're putting the chunks into the text and then embedding into the embedding. And then we're just running it and returning the response of this query. Now the second function is actually the most important function, is allows us to actually retrieve the context. So it does the semantic search or vector search that actually enables that retrieval augmented generation. So in this function, we pass in the query, essentially the prompt that you want to retrieve. We have the distance set to 3, and then we're passing in the database class. Now, again, we have the query embedding goes through Llama 3, and we're essentially capturing that embedding. And then for the vector search query that we're doing, it is a subquery. So in the inner query, we are doing the vector similarity search. So we're essentially taking the embedding from the chunks table, and then we're comparing it to the query embedding. And then we're checking the similarities of them. And this query essentially returns us both the text and the similarity. And then we're doing the outer query, which only selects the value of the text. So what's going to return is basically an array just with the context that we need. And then, again, we have this parameterized query that has both the embedding and the distance that you want. Now, that's kind of it for the setup of the database and everything we need on the back end. So now we're going to use Streamlit to essentially put this all into action on the front end. So Streamlit comes with a lot of helper functions. We've seen some before, like the st success. And we have other ones called st title here, which adds a title. We're going to call it rag chatbot. We also have a subheader. So here we have st.subheader, which is, of course, the mystery of the Floric, which we will get to in a bit. Now, after that, what we're going to do is we're going to call the function initializeDatabase that essentially now creates this vector indexes. And another great thing about Streamlit is that it has this upload file functions. It has these predefined components that we can use. So here we have st.fileUploader that allows us to specify what type of file we want to upload. So here I've specified that we want to upload a text file. And we have this check that basically says, like, if you have an uploaded file, here's what you need to do. So for the uploaded file, of course, we want to read it, and then we're going to split it into chunks. So that's for the split text function that we created earlier. And then we want to store those chunks in SurrealDB with a function we created earlier. And finally, we want to have this message that basically says we processed the number of chunks that we created, and so we can see that that was successful. And the next two if statements we have here is basically making sure that in the Streamlit session that we're creating, we have specified the models that we are using. So here we are using Ollama, and we're using Llama 3 in that. And again, for the messages, we're also creating a kind of message queue in the Streamlit session. So basically saying, if the message is not in the session state, please store it. And again, here's the for loop that basically says, for every message in the message states, please display it with using the st markdown. So st markdown basically allows you to display whatever markdown content you want on the UI. And here we now get to the prompting part. So here we have the prompt, and it's saying, this will display in the UI as a chat input with a default text of what do you actually want to know. And here's where we will be able to type our prompt into, and then we'll save it. And then we have this session state and messages.append, which will essentially append the prompt to the session state. So when we actually type in our input, it will display in Streamlit. And then it will actually display it in this markdown format. And then now we come to the retrieval part of it. So with this retrieve context function, we pass in the prompt that you will input through Streamlit. And then we specify that this is a context. And then we have the kind of like assistant that will be the large language model. We have two things for it. We have the system message, and the system message will contain the context. So we have the role system, and the content basically is the context we want to give it. And we ask the assistant to please use the following context to answer the question. And then we have here also the chat history, basically that we display each role and the content in the chat history. Now, Streamlit session state is essentially ephemeral. If you refresh, it'll be lost. There is a way we can also add SurrealDB memory to this, but that is a project for another video. The last thing we want to do is essentially stream the response from the large language models and display that stream in Streamlit. And that's what we're doing here with st.writeStream, and we can stream all those chunks. And the last thing we want to do is just append the LLM response so we can actually see it in the chat. So that's pretty much all it takes to create a very simple RAG-bot. As you can see, it is 135 lines of code with a lot of white space and new lines for making it formatted all really nicely. So it's actually not a lot of code. So when we go to displaying it, we can now run this, and then we can go to here. So you can see we have the RAG chatbot, the mystery of the Floric. We see that the database initialized successfully, and we have the upload component that we specified earlier. And here at the bottom, we have a chat input component. So what I'm going to say is, what is Floric? And obviously, Floric doesn't exist. But as it is a local model, it takes a little bit of time to come back to me. So here we are. I'm not aware of any specific term or concept called flork. And it is completely made up. And so this way we can evaluate that, like, yes, this was not in the foundation model, and so now we're going to add it. So here I have a description of what flork is. So now I'm going to put it in, and then we can see it processed one chunk because the description is not that large, so it fits in one chunk very nicely. Now again, I'm just going to ask the same question, what is flork? And now we can see that according to the provided context, flork is an ancient semi-aquatic entity from the gelatinous dimension of Glibnar 7. It resembles a shimmering orb of bioluminescent moss with 12 eye stalks and a perpetually confused grin, serving as a keeper of a whimsy in the High Council of Drippletons. There we are. That's what flork is. I hope you've enjoyed this quick walkthrough of creating a RAG chatbot where we explored the mystery of the flork. Was the flork what you expected, or was it something different? In any case, I thank you for watching, and I'll see you in the next one.